Hello, my name is Kuznetsov, and today I will talk to you about how our team tried to improve mortality predictions on mimic dataset by using external knowledge from scientific papers, or how we did knowledge transfer with transformers, or at least try to do that. So let me introduce you to the idea of knowledge transfer. Let's say a patient comes to a doctor, and the result of this visit usually is something like some structured data, medication diagnosis, laboratory tests, and also some unstructured data like doctor's notes and stuff. So the idea is that from time to time, doctor goes to some library or to the internet and looks through scientific papers in his sphere of interest, tries to learn something and improves his or her predictions regarding the patient, and not only predictions, but also like what is the best course of action to take and stuff like that. So the problem here is that currently there are almost 1 million papers published each year only in medicine, and it's usually not really feasible to look through all of those, even if we limit papers to some particular sphere of interest for a doctor. So what we would like to try is to somehow automate this knowledge transfer. So let's say we make artificial intelligence read those papers and try to use insights it gained from those papers on doctor notes, on the structured information to improve whatever. Like, for example, it can try to improve mortality predictions, but it can also improve diagnosis quality and etc. So basically, our idea is to use medicinal papers to learn some language or meaning representation, or to use other transformers that are already trained onto some data corpus, and then use those transformers to encode doctor's notes to add information, to add external insights to this data. So basically, this looks a lot like transfer learning when we are using model trained on one data set to do something with another data set. And we will be using transformers because this was an approach that showed the best results. And in particular, you can see here that we will be using BERT or Bluebird. It's a particular transformer trained on medicinal papers. So the question would be, can transformer do what usually doctors do? Like, can it learn some insights and add those external insights, add this information into some particular problem? And if it can do so, like, we would expect from doctor that doctor has some specialty, and let's assume that transformers can also have some specialty from being trained on a particular data set. Let's say data set of papers about respiratory diseases. This transformer should perform better on respiratory diseases than some other transformer. So these are two ideas that we want to check. And our method would go like this. We have some data set, and we would do some pre-processing of this data set. Then we will use some model or estimator on this data set to predict some target, and we will use resulting metric to compare different approaches between themselves. So we can have two ways to pre-process data, but we can use same metric and same estimator so that these pre-processing steps will be comparable. And of course, the difference in our pre-processing steps would be that in one case, we will use some structured data and TF-IDFs, turn frequency, inverse density frequency, fitted to a particular corpus of medicinal nodes. And also we can use the same structured data, but Bluebird transformer to encode these same nodes. And we will use same model, random forest model, to predict mortality of the patients. And we will compare ROC-AUG scores for these two approaches to see if we can improve our results by using transformers. Also, we will try to use two different transformers. One of those will be Bluebird transformer, which is kind of general transformer for medicinal purposes. And we will also use another transformer trained on CORT19 dataset, which is a dataset which contains a lot of COVID papers, but it's not only COVID papers, but papers about respiratory diseases, about viruses in general. So we will do the same pre-processing steps, but we will use two different transformers to compare how would these two different approaches perform for patients with respiratory diseases and for other patients. So these are the results. And we can see that the model that uses base structured data, like laboratory results, medicamentations, diagnosis, and also TF-IDF scores from doctor notes. It outperforms both the baseline model that uses only structured data and baseline model that also uses additional embeddings from Bluebird transformer. However, what's interesting is that baseline model underperforms transformer solution for a small sample of patients, but when we use all patients, we see that baseline model using only structured data outperforms the model that uses the same structured data in the same way, but also adds some transformer-based embeddings. And it means that transformers introduce some noise into this problem. So that's the first result we have. The second result we have is that we didn't find that transformers outperform each other on some specific data set. So we expect that Cord19 trained transformer would perform better for respiratory diseases, but we see that it performs better for both types of diseases, both respiratory and non-respiratory diseases. So to sum up, the results are that we didn't find evidence that transformers can add external information to some particular problem. And we see that TF-IDF were able to outperform both transformers and baselines. So it means that transformers probably introduced some noise, even though for small subsets of patients, they actually improved the results. Also, we didn't find evidence that transformers trained on some specific corpus of data related to, for example, respiratory diseases would outperform more general transformer. We think that Cord19 trained transformer outperformed another transformer because it could use longer inputs, like inputs of 768 words in comparison to Bluebird that can use just 512 words as an input. So to sum up, we have seen that probably transformers still could be used somehow for this particular problem. They could gain some insights. Unfortunately, we didn't find evidence that it is so. However, we should add that there are a lot of different ways to pre-process data, and we have found that the results are sensitive to the ways we pre-process data. However, we didn't find any case where transformer-based models will stably outperform our models. But you can pause video and see how many different ways are there that can be used to change some pre-processing steps. And we found that some of those improve some performances, but these are our results. Thank you for your attention.